Hi, greetings from VNR VJIT. I am K. Anitha, Assistant Professor working in CSE, AIML and IoT department. Today I am going to give a lecture on Introduction to Agentic AI. Agentic AI is a buzzword now in our computer science technology. Agentic AI is a technology. It runs on goal-driven and it is completely independently working without human intervention or minimal human intervention in complex and every time changing environments. Unlike rule-based and predictive AI, agentic AIs are working independently and it takes decisions autonomously in ever-changing environments. Nowadays, in every industry, health and customer care, customer support, in every firms, they explore agentic AI because of improving the performance and efficiency and exploring adaptability. Now, coming to the point of our discussion. So, the main contents today in our discussion are: what is an AI agent? What are the different characteristics of agents? Power of AI agents. Agents versus traditional programs. Difference between AI agent and agentic AI. Types of agents, agents and their environments. First, we have to discuss about what is an AI agent. An AI agent is an advanced software program designed to simulate human-like intelligence. It can take informed decisions and actions to achieve a specific goal, and it can operate autonomously and utilizing the large language models. Here, what is meant by LLMs are large language models are very powerful deep learning models which are trained on massive text data sets which can understand, which can learn, which can respond to the user queries. And next, the sophisticated algorithms are also used to analyze and adapt to new information and also refine their outputs. An agent is anything that can be viewed as perceiving its environment. It can perceives anything or current status of the environment by using its sensors. Acting upon that environment, it can use actuators. For example, if we take human agent, eyes, ears and other organs are acting as a sensors, and according to that sense, what is sensed by that sensors, the hands, legs, mouth and other body parts are acting as actuators to do certain actions and things. And next, whereas in case of robotic agent, for example, cameras and infrared range finders working as sensors and various motors as working as actuators to accomplish a certain tasks. Next, software agents. For example, keystrokes, file contents received from different network packages are sensor or act as sensors, and the input whatever it got, it displays maybe the displayed on screen different files sent from network packets as actuators. Next, we discuss about the characteristics of an agent. Agent has different characteristics. First one is autonomy. Next, proactiveness, reactivity and social ability. First one, autonomy. It operates without human intervention. It doesn't have any intervention of the any type of tasks or any type of instructions or predefined rules or certain defined set of tasks in agentic AI. And second one is proactiveness. It responds to the environment. Whatever the changes made by the sensors or whatever the input collected from the sensors, according to that, the agent has to do or accomplish its task. Next, reactivity. And the tasks are initiatives according to the actions, according to the input, whatever it got from sensors. Next, social ability. Interacts with other agents or human to reach the goal or a particular destination. The agent has to communicate with other agents or with the human certain tasks are accomplished by these set of communication levels. Next, power of AI agents. AI agents represents a paradigm shift in automation technology. It actually shifted from rule-based technology to automation technology. It can take self-decisions to work properly or to reach the destination. These intelligent systems are autonomously recognize the inputs, whatever got from the sensors, create action plans, and adapt to changing different situations without excessive manual intervention. For this, we discuss about 3 points here. First of all, advanced technologies. The leverages NLP, natural language processing, machine learning, and large language models to handle these tasks from simple to highly complex tasks. And next, dynamic adoption. Wherever the agent has working in one platform, it could be shifted to dynamically. It can access different inputs from the sensors. According to that, it adjusts different strategies based on real time data, maintaining accuracy and efficiency across variable conditions. And here the agent has to maintain the brief history of the different tasks, and according to the inputs, it can maintain some history, and whatever it take, the next step will be followed by the brief history of the tasks. And next, third one is autonomous operations, handling different types of process optimizations and customer interactions with minimal manual input required. Wherever the user has different queries, it can the user can give certain types of queries. It immediately the agent can communicate with the user and give responses to the queries. And next, agent versus traditional programs. How traditional autonomous are working there in previous days. First of all, the task function. System receives a series of repetitive tasks requiring automation. Whatever the automation it is required in that situation, the system receives some series of repetitive tasks that can only accomplish or reach that goal. Next, rule definition. The user has to, or the human has to define some rules to complete the task. For example, business rules, scripts, and workflows are clearly defined and configured previously whenever going to reach the goal or fulfill the task. And next one, tool setup. Different tools are required to complete the tasks to the agent. RPA, robotic process automation. Bots are programmed to execute specific rules. These are the simple agents which are used or user friendly to the user friendly to the customers or any type of users. And next, event detection. System detects triggers like from submissions or document uploads. Whenever the user has to submit any type of data, and whenever he trigger any submission button, only the data can reach it to the agent in the form of input by using some sensors. Next, task completion. Automated process executes and notifies relevant stakeholders. Only the stakeholders can come that the task is completed only said by them only. The traditional automation work is completed. Next, how the AI agent can works in this scenario. First of all, the agent has to gather the different types of inputs from multiple sources across various formats. In first step, the all data whichever wants by the agent will be gathered. In the next step, interpretation, by using machine learning and natural language processing to understand context and nature of inputs. These multiple resources having different types of or different formats of inputs, all these inputs will be gathered, and then some processing or pre-processing tasks are accomplished by the different tasks, different types of techniques. Next, and these are understood by the machine learning models and by using with the help of natural language processing. And next, third one, decision making. Determine actions based on training data and real time learning. the decisions will be made by the agent. It will be one model can be trained by different types of data models, and then the real-time data will be accomplished at the time of running level. Next, system integration, connecting to the different types of application programming interfaces and databases. These data will be streamed through network or web or anything, and tools to execute the different types of tasks here. Next, finally, the continuous learning, the agent has to trained depend upon the feedback which it got from the performance levels and accuracy levels in the form of performance and accuracy levels. It is trained level by level. After it could improve its performance based upon the feedback. Next, agents in agent versus traditional programs. The mainly the key differences at a glance. In case of adaptability, the traditional systems cannot handle changes well. And next, whereas in the case of AI agents, easily adopt and respond to changes. Next, in intelligence level, the traditional systems follows predefined set of rules only. They cannot take autonomously decisions. They cannot work independently. Whereas in the case of AI agent, it learns from interaction to make a smart decision. This is the main and efficient point whatever we got from traditional to AI agents. And next, in case of data handling, the traditional systems works best with structured data, whereas in agentic AI, the agents can work with structured or unstructured data and also the mixed data. Next, human interaction. The traditional systems here the human interactions will be limited, and whereas in AI agents the interaction of the humans are natural, context aware conversations only. Next, difference between AI agent and agentic AI. Here we have discussion about what is the AI agent and what is agentic AI, how the performance will be grading. And here we discussed about the difference between AI agent and agentic AI. First of all, we have to discuss about what is AI agent. AI agent refers to a system or a program that is capable of autonomously performing on behalf of a user or any other system. An AI is a system that perceives its environment, means it can see or it can views whatever the changes according to the tasks accomplished in the environment. And next, think or reason. The agent can think or certain reasons are there to do some tasks. Here AI models are logic to understand. And next, acts to achieve goals, responses, some of the performance actions, and some are the gathering results. So an AI agent is a system or program which can perceives its environment, which can thinks or reasons by using certain AI models or large LLMs, and next it can act to achieve goals by responding, by performing some actions, by using some of the API tools, and then generating the results. Next, here we are discussing about the example of an AI agent. While an LLM, it can generate code, we can equip it with a code interpreter tool. For example, if we take a query to the agent, generate 345th Fibonacci number, the agent can write the code. First, it can executes it using the interpreter, and it returns the computed answers accurately. This makes the agent truly interactive, tool augmented, and goal oriented. And core characteristics of the agentic AI. Here, the single agent can access multiple number of tools. First of all, it can write the code and then executes it using the interpreter, and it can returns the computed answer accurately. This makes the agent very interactive to the tools. And then next, key features of AI agent: reactive, responding to the predefined triggers or user requests. The main key feature of the AI agent is reactive, responding, and predefined triggers or user requests. Next, limited autonomy and learning. Here it has limited autonomy. It doesn't have complete autonomous to take its own decisions. And then large language models are working as like brains of the agents. These are frequently used to power tools, custom functions, or transition to specialized language models for particular tasks. In AI agents, large language models or special language models are working together to accomplish the task. Whereas in case of agentic AI refers to AI systems that operate with a degree of autonomy and agency. They don't just respond to prompts or triggers. They plan, they adopt, they reflect and interact across dynamic systems. This is the main difference between the AI agent and the agentic AI. So here the main difference here we consider that the AI agent cannot individually taking decision, and then it can not only responds to prompts or triggers, they can plan, they can adopt, they can reflect, they can interact across dynamic systems. For example, the autonomous travel planner has a query that he wants to book the flight, hotels, and do certain activities by understanding the user preferences. Here, the agent can do certain things in serial. First one is checking the real-time data, whether the conditions of the weather is good or not, whether the traffic is clear or not. And second task is adjusting plans independently to meet the goal. To meet the goal, certain conditions are there to reach. Next, demonstrating reasoning. What are the weather conditions and what are the adjusting of the plans will be carried in the form of input, and in this case the agent can reasoning the situation, and then planning and what type of flight he wants to book, and he wants to travel, and which type of cost effectives, timings. These are all regarding the planning tasks. And then action without constant human input. And the once the user has a query, one time only the user has asked to book the flight, and in all of these tasks the human cannot intervene these tasks. The agent can only book the flight, hotels according to the according to his dates. Okay, this is the main difference between normal agent AI or and agentic AI. Next, regular AI systems versus agentic systems. Here, certain number of features are there. First, we have to discuss about autonomy. In regular AI systems, the agent has to execute different tasks only when prompted. When it gets the prompting from the user, only it execute the task. Next, whereas in the case of agentic AI system, it operates independently. It can initiate actions without intervention of the human. This is called autonomy. Next, adaptability. Here, in regular AI systems, static, based on training data only, the agent can act. Whereas in the agentic AI systems, it learns continuously and adapts to context. Next, in decision making, offers insights requires human approvals. Whereas in the case of agentic AI, it makes and executes decisions autonomously. It can take its own actions according to the environment. Next, behavior, reactive and task specific oriented only the agent can do here. Here in agentic AI systems, proactive, multi-step and goal-driven tasks are accomplished. Next, examples of regular AI systems are chatbots, predictive analytics tools, and grammar checkers are the best examples for regular AI systems. In agentic AI systems, AI trading boards, logistics, optimizers, autonomous co-pilots are the best examples. Next, governance needs. Here in regular AI systems, data oversight, accuracy checking are the main activities in agents. And here, the in agentic AI systems, continuous monitoring of the behavior of the environment. Here, the agent can follow some sort of ethics, and the outcome should be taken as the feedback, and the agent can trained level by level according to that feedback. Next, coming to the point of types of agents. Artificial intelligence enables machines to perceive reasons and act intelligently. Here, the agent can make decisions and performing certain tasks based on their environment. It ranges from simple rule-based systems to advanced models powered by large language models. Large language models are the deep training models which are trained on massive data sets. Next, AI agents can be categorized according to their intelligence level, decision making approach, and interaction style with their environment. Here we have the types of intelligent agent. First one, simple reflex agent, model based agents, goal based agents, utility agents, and last one is learning agents. First one, simple reflex agents. Here it is the most basic current environmental condition based agent. Here the predefined or set of rules will be defined to the agent by the human. It doesn't have any type of experience or future consequences. For example, a thermostat adjusts based on the current temperature. Its heat based on the current temperature. And next example, the automatic traffic light changes signals based on their sensor inputs. Since the lack of memory, the same type of mistakes are repeatedly happens in this simple reflex agents. This is the main drawback in this agent type. It is the poorly in dynamic or complex environments. This one is the architecture diagram of simple reflex agents. Here we have the environment. This environment is perceived by the sensors. Here it is the agent system. The sensed data will be analyzed here what the world is like now. And next, what action should I do now? What type of action, what type of data is there in current situation? And next, what type of action can I do? This will be carried out by the actuators, and action will be done and then go to the environment side. So this is the simple reflex. This action will be done according to the rules which are predefined by the human. And next, second type is model based reflex agents. It is the advanced form of simple reflex agent and uses condition action rules along with the internal world model which keeps track of the current environment. So here, whereas in simple reflex model there is no internal world model, but here it can follow, it can have to implement internal world model and also along with the condition based action rules. It remembers past interactions whatever made by the sensors in the environment to the agent to make better decisions. And next, here one example we have to discuss. The robot remembers obstacle locations while navigating a room. It can remember where is the different types of hurdles are there, where is the obstacles to navigating in a room. It works well by recalling past states. This makes the more flexibility and adaptability when compared to the simple reflex agents. However, here is also one disadvantage. Still, the lack of deep reasoning or learning abilities for complex tasks. Here, the implementation of these type of agents are very difficult in complex environments. Here, the model-based reflex agents architecture is there. Here also, we have environment perceived by the sensors, and it will be analyzed what the world is like now, what is the current state, and how the world evolves, and what my actions do. The agent can analyze by these three steps. After that, it can decide what type of action I can do now based on some conditions. After that, these certain tasks are accomplished by the actuators. The action will be going to the environment likely. Next, this is the third one, goal-based agents. This is the extension of simple reflex agent with goal-oriented decision making. Here, previously we have no goal-oriented decisions. Only the extension of, only in this model, we got the goal-based agents. Here, the set of plans, set of actions to achieve a specific goal already predefined. For example, the robot navigating building plans, it can go to target room while avoiding different types of hurdles. These agents are common in robotics, automation vehicles, and simulation systems for goal-driven tasks. Here also one disadvantage there. The smaller than simple reflex agents, it will depends on pre-programmed strategies only, because here we have the internal world model. So according to that model only, the pre-programmed strategies or decision trees are accomplished. Next, this is the architecture. Here also we have some sort of steps to analyze the data, whatever they senses from the environment. What is the state, how the world evolves, what type of actions can do. Here, in place of conditions, we have certain goals. Based on this goal, the actions can be performed through the actuators and it can go to the environment. Next, fourth one is utility-based agents. Here, the agent can consider one function. Which one is the best function? It can decide. There are multiple possible outcomes are there, assigning each utility function value to choose the best optimal action. For example, in case of self-driving car, it can balance speed, fuel efficiency, and safety precautions using utility scores. And next, another example is there. Here, the e-commerce platform uses such agents for dynamic pricing and product recommendations. Next, these agents work well in complex and changing environments. Here also one drawback is it is difficult and requires analysis. Many influence factors are there. Next, this is the architecture. Here, in place of goal, it has some utility function. The variable has to update in utility functions. According to that, the actions can be performed by the actuators. Next, this is the last one, the learning agents. A learning agent improves its performance over time using new data and experiences. It can update its behavior based on the environment feedback instead of relying on fixed rules. It can't consider any type of fixed rules. It can update its performance according to the feedback what is getting from the in the form of environment, in the form of output. Here, the valuable chatbots and social media where NLP helps analyze user behavior and improve its interactions. Here we have the 4 types of components in learning agent. First of all, performance element, learning element, third one is critic, and fourth one is problem generator. In performance element, here we see that performance standard. This will be considered different factors by the agent. And next it comes to the critic. In critic level, each and everything will be gained by the agent in the form of feedback. And next, the learning agent will be learned from this feedback, and it can reach the learning goals. And then the problem generator in future, if it has any type of situations, the problems can be different types will be generated by the problem generator. And according to the learning element learning goals, the changes will be made through the performance element, means the variable values will be deferred, and then it gains knowledge. And the different types of experiments are explored by the problem generator, and then it will be affected in the future conditions. And next, what are the different characteristics and best use cases of agentic AI of different types? First one is simple reflex agents. In characteristics, it can have immediate response, it cannot maintain any type of memory, and it only accomplish the simple tasks. And then model based reflex agents. Here it has internal model, and it handles partial and observability, whatever the tasks here. And then it can implement in complex environments. Next, goal based agents. It can plan set of actions based on future consequences. And in the best case here, the goal based agents will be implemented in navigation systems. Next, utility based systems. It maximizes the expected utility. And in case of financial trading systems, here we are using utility based type of agents. Next, learning agents. It adopts the different performance levels through the experience. Next, personalized recommendations. In case of personalized recommendations, the learning agents will be developed. Next, different types of environments are there. Here, the environment refers to the surroundings in which AI agent can operate and interact. Means where whatever the agent, what type of operations, how it can interact, that is called as environment. Based on its surroundings, only the tasks are accomplished or implemented. Here, the type of environment greatly influences. Here, first of all, AI agent can learn what it learns from the environment. Next, makes decisions. What type of decisions it can take, it can decide. And then reacts. What type of reactions is there after completion of the task. Next, we have different types of environments. First one is deterministic versus stochastic. Next, discrete versus continuous. Next, static versus dynamic. And then fully observable versus partially observable. First, coming to the point of deterministic versus stochastic, means here in deterministic environment, it completely predictable. 100% predictable things are there in this deterministic environment. There is no randomness, and different types of causes are there. It affects a line. Means any made changes in the environment will affect overall the system. And for example, TikTok toy. Every move will be predictable here in this TikTok toy game. And then stochastic environment. Here random and uncertainty is there, means there is no clear or clear tasks or clear environment is here. Here in this stochastic environment, random and uncertainty is there. There is no certainty. And next, variable outcomes will be presented. And then think probabilistically. For example, here if we take the rolling dice game, weather forecasting and stock trading. It is uncertainty is there. There is no damn sure or there is no surety of the things whatever it happens in that environment. Next, the second one is discrete versus continuous. In discrete environments, chess and other board games are coming under the discrete environments. Text based AI systems, natural language processing with tokens are here under comes the discrete environments. Next, board games. For example, if we take the turn-based strategy games, whatever the coins moved in chessboard will be according to the opposite person strategy. And then coming to the point of continuous environments, here robotics control systems, robot arm motion planning, and autonomous driving systems are there. In continuous environment means autonomous vehicles, industrial automation with sensors will be continuously going on. Its tasks will be its task will be coming to reach the specific goal. Next type is static versus dynamic. Here it remains unchanged unless the agent acts. Any certain task will be implemented by the agent. Then it can changes the environment. Next, waits for the next action. It can wait for the next action. It doesn't involve or evolve any type of task independently. Next, it has long-term planning possibility. For example, puzzle solving. Next, dynamic environment. It can change constantly independent of the agent's actions. One by one actions is going on according to the changes made in dynamic environment. Environment keeps evolving, forcing continuous adoption. It requires mid actions or mid plan adjustments because the environment is dynamically changing. Next, for example, autonomous driving. In autonomous driving, the cars, the pedestrians, different types of vehicles are coming continuously on road according to the different speed breakers, different types of signals are there. These are all continuously changes in environment or happens in dynamic environment. According to that, the autonomous vehicle has to move forward. Next, fully versus partial observable. Here in fully observable environment, the complete information about the environment will be input to the agent, and then no hidden data. There is no hidden data. Next, clear decision making will be happen because the all are open, all are known things to the agent in fully observable environment. For example, if we take chess, all pieces are visible and there is perfect information on chessboard. Next, partially observable environment. Here, the incomplete information is there. Hidden variables. There are number of hidden variables are there. There is no clarity about that variables in that environment. Uncertainty is there. Number of decisions and number of tasks will be in uncertainty mode. For example, poker game. Hidden cards are there and there must be incomplete data. So these are the different resources which are gathered all these data from the following. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.